Then today we're going to talk about inequalities that involve two triangles. We're going to deal with the Hinge Theorem and its converse. And before I actually walk through the Hinge Theorem, I kind of want to talk about why it's called a Hinge Theorem. Notice you have two sides in each of these triangles that are the same. But this included angle is different. So I can see the triangles aren't congruent. So let's talk about why they call it a Hinge Theorem. If we could imagine just for a minute that these two sides are fixed sides in a triangle, and that this angle that's in here could be adjusted. Okay? But these two sides are going to stay exactly the same, whatever they are. But if these two sides could actually be adjusted, what happens to the third side as the angle gets bigger? The third side would get what? Bigger. So it's hinged on this vertex of this angle. What happens as it gets smaller? The side gets smaller. So, if two sides are the same, and the angle that was included between them changed, in other words, the hinge moved, and it started out big, and it got smaller, angle A is bigger than angle D. What can you tell me about the sides then that are going to be opposite of it? Which one's going to be bigger, BC or EF? BC will be greater than EF. If two sides of a triangle are the same, and this included angle is different. In other words, the hinge was adjusted. They made it in this triangle so that the hinge was open a little further. Then the side that's opposite where the hinge was got longer. BC had to be greater than EF. Jesse?
So everything else will be the same but BC and EF?
Yeah, well, this angle changed, obviously, right?
Yeah, side.
And this angle might well have what? Changed, but that's not what we're comparing. The only thing I can compare is what? BC and EF. We good? The converse of this is also true. If two sides stayed the same, if I stretched out the third side, what happened to the angle of the hinge? It got bigger. If I made the third side smaller, then the angle got smaller. Since two sides are the same, obviously BC is greater than EF. What can you tell me about the measure of angle A compared to the measure of angle D? Angle DA has to be greater than angle D. If two sides of a triangle are the same, but the third side is different, there's an inequality, then the angle that's across from the larger side will be larger than the angle that's across from the smaller side in the other triangle. Questions so far? So let's talk about comparing some triangles then. In example 1, we're using the Hinge theorem. Notice 5 is the same as 5. 9 is the same as 9. But the angle that was stuck in between, 80, is different than the angle that was stuck in between 75. 80 is larger than 75. So which side is larger, AC or DF? AC is larger. There's my inequality. AC is greater than DF. It's called the Hinge theorem. This is the converse of the Hinge theorem. Notice that the 19 is the same as 19, that the 11 is same as 11. But the third side didn't stay the same. On the third side, you can see that the side length changed, so they're not congruent. What can you tell me about the angle then that's across from 23 compared to the angle that's across from 26? They're not the same. In fact, which one is smaller? Angle M is going to be smaller, so angle M is less than the measure of angle P. Just about. Questions?
I do have a question on the last one, but that's the same.
Which, on example 1 or the other examples that are coming up yet?
The other example.
Okay. I would expect you to have questions there yet. We haven't talked about them.
Example 3, yeah.
Okay. Example 3 and example 4, both of them have something in common. Notice the 8 and the 8 are the same. I only see one set of congruent sides. The other congruent side is the one that uses the reflexive property. So the angle that's stuck in between the 8 and the XZ is 51 degrees. And between XZ and the 8 is 55 degrees. Which segment, WX, across from 51, or XY, across from 55, then, is going to be the greatest? The XY is going to be greatest, which means WX is less than XY. Example 4 is the converse again. We're not looking at which side is going to be different. We're looking at which angles are going to be different. We see one set of congruent sides. The other congruent side is the one that's reflexive. So the third side that I'm looking at is 3.6. It's across from this angle. And the 3 is across from this angle. Which angle is going to be bigger? The one across from 3.6 or the one across from 3? Yeah, the one that has F in the middle. We can't call it angle F because there's more than one angle there. But if I go BFC, this one is going to be larger. So FCD is less than BFC. Questions?
So, like, 3.6 on the way to F.
Right.
And 3 on the way to C. Both of them are going to be in the middle every time.
They're always going to be caught in between what? The two sides. But notice the C and the F are in the middle. Why? Because this is where that angle is. It's at point F, so it has the vertex of the angle. And this one's at C, so that's the vertex of the angle. It'll be in the middle.
It's always
Always in the middle. Other questions? Okay. These are the ones that if you're not paying attention, you'll miss a piece of it. Here they're asking me to find a possible range of the values of x. You'll notice 4 is the same as 4. 8 is the same as 8. But the third side is not equal. Which of these is going to be greater? The 5x plus 2 or the 67? 5x plus 2 must be greater than 67. We solve an inequality just like we would an equality. I've got to get this x by itself. I'm going to subtract 2 from both sides. I have 5x is greater than 65. And now I'm going to divide both sides by 5. X is greater than 13. This part most people will get, but there is another piece to this. And it could be one of two ways when you're dealing with an angle. An angle cannot be larger than 180. It's got to be less than 180, right? But it also have to be greater than 0. I'm already comparing x as being greater than something. So where this 5x plus 2 is, it has to be less than 180. There's no way that this angle can be equal to 180 degrees. Has to be less than that. And I would solve this portion as well. I'd subtract 2 from both sides. I'd have 5x is less than 178. And I would divide both sides by 5. X is less than 178 over 5. Or you could put 178 divided by 5. 35.6. So, the answer says x has to be greater than 13, but less than 35.6. So there would be two pieces to this one. You can write it in one statement or you can leave it in its two separate pieces. Either way is okay. When you're dealing with an angle, it's important to know that I don't always compare it to 180. If this was less than, I would have compared it to 0, and I would have said it had to be greater than 0. So when you're looking for that second possibility, it's possible that instead of comparing it to 180, I would have compared it to 0. Just depends on the way the problem is written. With a side, the only thing I can possibly compare it to is 0. And then whatever I get out of the problem. If you look at example 6, 9 is the same as 9. 5 is the same as 5. And I'm going to compare this other side. Which one has to be the biggest? 2x minus 4 or the 32? 32 is bigger. And I'm going to solve this the same way I would an equality. I'm not going to subtract 4. I'm going to what? Add 4 because it was already being subtracted. I now have 2x is less than 36. And I'm going to divide both sides by 2. X is less than 18. What does 2x minus 4 have to be greater than? This is a side. What does it have to be greater than? It can't be negative. It's got to be greater than 0. And I'm going to solve this piece by adding 4. I now have 2x is greater than 4, which means x is greater than 2. Mm-hmm.
Why? Yeah.
Okay.
And then get that boy crazy like why did you have to use it?
Let's take a look at a couple more.
How would you write the answer?
Either way, you could write it as 2 separate pieces. I personally like to put it together in one piece. It shows me that x is bigger than 2, but x is smaller than 18.
Okay.
Let's look at example 7. You'll see the side that was marked as being the same. I see that I've got another side, 50 and 50. But I've got this angle in here that's different. What can you tell me about what's across from 68 compared to about what's across from the 55? Which one is bigger, the 47 or the 5x plus 2? The 47 has to be larger. And I'm going to solve this the way I would solve an equation. I'm going to get rid of the 2 by subtracting it. I now have 5x is less than 45. And I'm going to divide both sides by 5. X is less than 9. The other piece is going to be this. What do we know for sure about 5x plus 2 because it's a side? It has to be greater than what? 0. And I'm going to solve that piece as well. I'm going to subtract 2 from both sides. 5x is greater than a negative 2. And I'm going to divide both sides by 5. X has got to be greater than a negative 2/5. And if you took 2 and divided it by 5, it would be the same as negative 0.4. X has got to be bigger than negative 0.4, but it has to be less than 9. Please, it's okay for x to be bigger than a negative. It's not okay for a side to be what? Negative. If I put in a negative number like a negative 0.3 here, this side would come out to be positive. That's all that matters. Even if I plugged in 0 for x, this side would become 2. It's okay for x to be 0, just not for the side to be 0. Last example. I see that I have a side that's marked as being the same. The other side is the side that's reflexive. So what's across from the 11 has got to be bigger than what's across from the 9. 6x plus 15 must be greater than 65. I'm going to subtract 15 from both sides. 6x is greater than 50. I'm going to divide by 6. This would actually come out to 8.3 repeating. I'd rather you left it as a fraction. Question? I would simplify it. It would become what? 25 over 3 or 8.3 repeating. Jesse?
Like, why is it that 6x plus 15 is greater than 65 when in the last one 5x plus 2 wasn't greater than 47?
Okay. 68 is larger than 55. So whatever is across from the 68, which is 47, had to be the larger side compared to the 5x plus 2.
Okay.
You with me?
Oh, no.
There's another piece that's missing here. This is dealing with an angle. So the angle has to either be bigger than 0 or less than 180. I'm already comparing x to something that it's bigger than. So I need to do the 6x plus 15 has to be less than 180. And I'm going to subtract 15 from both sides. 6x has to be less than 165. Which means x has got to be less than 165 over 6. Which would simplify to 55 over 2 if you wanted to reduce it and leave it as a fraction. Or you could put 27.5. X has got to be greater than 8.3 repeating. It has to be less than 27.5.